Okay, this is test number 1 of the JLD404 amp hour meter. It's currently measuring amp hours in, and we are pushing 6 minutes, 25 amps, 13.8 volts. So we have is our trusty 36 volt 30 amp kind of power supply charger here, supplying current. I've got the 12 volt for the amp hour counter just coming from a gel battery at the minute. We're going through the 1000 amp shunt, which is has been encased in this potting compound by the guys at EVTV. And into this we're going into our new module of 16 headway cells. So this is a 64 amp hour 12 volt, well normally 12.8 volt battery that I'm just experimenting on here before I install it in the car. So I just decided it'd be a good idea and a good chance to test some fresh cells and include the amp hour counter in the testing. Now, these cells have never been balanced. They're straight out of the box, so I'm just going to basically just push some amp hours in there just until the first of them hits about 3.6 or so, tail it off. We'll just see how much that we can actually stuff into the cells when they turn in. And so far, even standing way back from that display, I can see it very clearly, which is a major plus. And I'm just going to continue on and do some more tests. Okay, so throttle back the charging current to about 10 amps because the most right hand group of cells gone to about 3.65 volts, so I'm pushing 25 amps into them. Then, as you'd expect, back to about, it came back up now to about 3.68 or so with 10 amps of current. 3.451, 3.400, and 3.432 right to left. So I'm going to put the amp hour counter back onto current, so pushing 10 amps. I'm now going to go ahead and just reduce the current to 5 amps. Oop. There we go, 5 amps. Then we go back to our rightmost block of cells, around 3.62 volts, and falling back a little bit. Then we're at 3.430, 3.390, 3.417, 418 volts. So, interestingly, 0.05C for this pack would be 3.2 amps, which is where I normally terminate the charge when it's in the car. And as far as I'm aware, that's what is recommended. So from an amp hour perspective, we've put just over 4 amp hours into the battery. So just from a perspective of looking at how much power we've got in here, 3.6263 volts on that. But, this little meter looks to be pretty good. The only other means to have in the car with a shunt on it would be the Victron BMW 600 HS, which is a horrendously expensive piece of kit, and the display on it is rather small. I'm back around 6.5 there now, so I'm going to up to amps. I'll let her down a little bit, around 23 amps. Go. What's amazing me is that I've got a 1000 amp shunt here. I'm down here able to measure very small parts with it. Back to around 3.63 volts or so now. So we'll be approaching the point that I would actually be cutting off the charger. This particular power supply stroke charger that I have here, I believe it was originally designed for charging 24 and 36 volt pallet jack type batteries, so, but it's got a good current adjustment on it, so it makes a handy high powered bench power supply. So 4.2 amp hours is what it has taken so far, just been stuffed into this battery to actually bring the first block up to just over the knee. Just zoom back out a little bit there. You can see the setup that we showed before. Literally just a headway pack, current shunt, ammeter, and power supply. So the next part of the plan is I'm going to rig up a load, going to zero that amp hour counter, to rig up a load, and we're going to see how many amp hours do we get out of that battery before a cell hits 2.5 volts. Then what we're going to do is we're going to employ the other light object voltmeter to affect the bottom balance on that battery. Then we're going to use our trusty Chinese pallet jack charger to charge it back up, then repeat the exercise till we see just what we get out of this battery after it's been bottom balanced. So just do a zoomy back in there. This is really like watching paint dry, it has to be said. But you know, what is he going to do on a Saturday? You know, sit out in the sun, practice your golf swing. It's not really my style. Okay. Let's just read out the voltages again. So from right to left, 3.66, 3.413, 3.380, And finally 3.407. So I'm going to terminate charge at that. And we'll just go over to 20 minutes, 0 amps, and about 13.5 volts. The voltage, we're down in the weeds with this, with only 13, or I should say only a 4-cell battery, so it's about 0.1, 0.15 volts off. That's good enough down at this low level. So next move is I'm going to rig up some kind of a load. Okay guys, we're back. So we've rigged up a kilowatt contactor, and just got a circuit breaker there just to switch 12 volts to the contact, or I should say relay coil, and we've then got some cable coming over here, and we've hooked in a motor. Ooh, there goes my swinging camera. I seem to operate a kind of a home for forklift motors here that want a bit more adventure in their lives. This particular one is an 80 volt pump motor that I recently acquired. I believe it's made by Siemens, and it runs very smoothly indeed. I have no idea how much current it's going to draw, so we're going to just set up again here with the just going to get a little bit of a better picture there. So the first thing we're going to do is we're going to zero the amp hour count. Now, according to Jack's instructions, to do that by holding the down arrow for 3 seconds. And there it goes. Okay, so let's go on to current. Voltage is good, 13.3, there's current. And let me make sure this motor isn't going to jump around on me. Wedge something under it. There we go. Now it should be free spinning. Let me just verify that. Yeah, there was a dent in the fan housing, which I managed to knock out of it. So let's zoom in on the meter section. There we go. I'm just going to go ahead and kick on the kilowatt. So here goes, folks. We're drawing about 12 amps or so. The motor's running sweet as a nut. Fan's running, good bit of airflow on it. So now if we go to amp hours, voltage, there we go. So that's actually now counting amp hours out of the battery. So this should be interesting. Have a look at the voltage here. 13.38 volts total pack. Right to left we've got a 3.333. 3.341. The motor isn't drawing more current. I have to put a load on it to make it do that, which isn't the easiest thing in the world to do. So got a 11 amps of draw. So we'll come back when we're a bit more down, and we'll see how we're faring out. Alright folks, slight change of plan. The motor was only drawing about 10 amps, so I need a way to speed up the discharge and have it a bit more controllable. So what I decided to do is to hook up this 1500 watt inverter that I had hiding in the shed there. It's a pure sine wave 12 volt input, and to that I've hooked up this, you can see it too well in there, it's just a 400 watt little frost prevention heater, and let's get a look in at that there. As you can see, it's drawing about 48 amps from the pack. Just getting a little bit closer there on that, and ooh, it's sliding. So let's see what we've got. 12.5 volts. As you can see, the amp hours are counting down just a little bit quicker now with that on there. So that should speed up the process a little bit, and what I can do then is just plug in different things into that inverter just to vary the current draw. So counting away happily there. You don't have to look up the instructions for getting it cycling, so that would be a handy feature. So I'm going to see if I can I'll have a look through the instruction booklet now and see if we can set that up. In the meantime, get my broadcast quality camera here to zoom in on that display a little bit. There we go. I think I'm getting better at this. Right, so looking at our instructions. Okay. Okay, right arrow key, momentary press steps, hold for 3 seconds, display function automatically cycles. So right arrow key, hold down for 3 seconds. There we go. 48 amps, 12.5 volts, 7 amp hours, and 27 minutes. Okay. Sweet. So now I just have to avoid that heater and maybe work my way around the other side of the motorcycle. Unfortunately, my workshop space is rather, what would be the word, confined at the minute. Too many projects, really. Way too many projects going on. I have to work my way over here. Sorry, getting my arm in the way. Oh, there goes the meter. Okay, we can set up on top of the inverter. And so at 48 amps approximately, with a pack voltage of 12.85 volts. From right to left, our cells are 3.221, 3.160, 3.205, and oops, daisy, I'm doing that one. That's the last one, 3.221. So all good on that front. Walk around the motorcycle again. Going to need a bigger boat. Okay. So okay, we're clocking out amp hours. So when we get to the point that the battery is getting down towards cutoff, we'll come back and see how we fared out. Okay guys, we're at just over 21 amp hours. All systems are go, and we have got a little bit, about 49 amps. It's reporting 12.4 volts, but I've actually measured on the terminals 12.75, so close enough. And I noticed that as the amp hours passed over 20, we went to 1 decimal point. So that's about it. Alrighty folks, we just passed the halfway point, and I'm going to get the multimeter on here now, and let's see what we've got in terms of voltage. Now, we have a total pack voltage of 12.43 volts, and again right to left, 3.170, 2.896, 3.128, and 3.189. So it looks as if cell number 2 is going to be the one that has the least capacity. So, very interesting, Mr. Bond. So let's make my way back around this way again and see what our amp hour meter tells us that we're doing in terms of current. So we're doing about 50 amps. Which makes sense because as the voltage drops, the inverter will increase the current draw in order to maintain the same output voltage and current. And it's reading 12 volts, but we're about 12.3 or so. So, a little over half the battery capacity expended. At less than 1C. I'm going to take a guess that we're not going to see much better than not really going to see much better than 40 amp hours. It's just going to be my prediction. Probably turn out to be complete nonsense. 2.827 now on cell number 2. Everything else is still well over 3.1 volts. So what we're going to be doing, so if we get down to about 2.5 volts on that cell, I'm going to come along and turn off the heater. We'll put a smaller load on there, and we'll see what we get. Well folks, turns out we got 37.7 amp hours before cell number 2 dipped below 2.5 volts. So that's interesting. So the next part of the plan now, to plug a lesser load into the inverter and see if we can draw out any more energy, and then we're going to go about bottom balance, which will pretty much trash this reading, and then we will charge it and see how many amp hours that we get back in. So I'm going to set up now with just a inspection lamp or something and see what we can get back out. Alrighty, just set up a 150 watt incandescent lamp on the inverter, and it's drawing about 15 amps from our battery, and I'm just clocking up some amp hours there now, so we're up to 38 amp hours. My way over here, and let's go across our cells again, see how we're getting on. So we are at 3.261, 2.945 is dropping, 3.116, and 3.267. So it's plain to see in this case, oh, my cats are talking to me. It's plain to see in this case again that it's cell number 2 that is cell number 2 that has the least amount of charge in it. We're at 2.92 volts and falling. So when we get to 2.500, I will shut the inverter off, and then we will initiate a bottom balance, and we'll have to set up the other programmable voltmeter for that, and some other odds and sods. So once I have that done, we'll come back and watch some more paint dry. So there we have it, folks, the verdict's in. We got a total of 39.6 amp hours out of that battery before a cell fell below 2.500 volts, and that was only with a 15 amp draw for the last 2 amp hours, 2.5 amp hours. So we're now going to do a bit of reconfiguring here on the bench and see about setting up to do a bottom balance. So stay tuned, more to come. Alrighty then, we're in bottom balancing mode now. We're on our 3rd cell block. We've got 2 of them done, and we're achieving that through the use of this light object programmable voltmeter. And this little guy has got a lot of strange kind of settings on it, but in short, what it can do is control a relay with 2 programmable voltage settings that turn it on and off. And at the minute we've got it set up to turn on at 2.70 volts and turn off at 2.50. And what that does is it controls a 12 volt supply to this kilovac here, and that's connected with some cabling to the cell in question. In this case, this is our 3rd cell here from the right, and it's set up, and we've set up our trusty forklift pump motor here as the load. Now with a 3 volt supply that draws about 18 amps, and it just turns over a couple of RPM, so it's just a handy dump load. A resistor would be probably a better choice, but I'm just kind of working with what I've got today. So what we're doing here is pretty much hooking up each cell to this load, and basically what's happening is that as the cell voltage climbs back up, the load comes on, pulls it back down to 2.50 and turns off again. So what we're actually seeing is that the cells typically settle down to just below the upper limit of the set point. I've done a few experiments with this meter over the past fortnight or so, and it's a very handy method of doing bottom balancing. I'm going to have to get a couple more of these and actually build up a proper bottom balancer, but just for today we just got it spread across the bench. So once we get all of our cells pulled down with this piece of kit, I'm going to go ahead and reconnect the JLD404, and we'll turn on our power supply stroke charger, and we'll see how much energy that we can put back into this battery here before a cell starts to hit the upper knee. And I would hope that we get in more than 40 amp hours, and then we can actually discharge it to a couple of charge discharge cycles, and we'll see how the cells behave both down the bottom end of their charge discharge curve and also up at the top end. So I have to say these little meters are quite good so far, and so that's about it. So I'm going to just continue on. I'll video a little bit of the last cell there as it's discharging and cutting off. But the big advantage of these meters is that you can actually just go away and do something else while it performs the balancing function. Watching a movie at the minute. So that's about it. We'll be back for the final cell, and I'll hopefully just show the thing cycling on and off. Oh yeah, before I do that, just a few little points. If you're setting this up, it's very important to have a separate sensing wire going to the cell. If you try to sense the voltage through the cables that are drawing the discharge current, ultimately what happens is that the voltage drop across the cable, because we're dealing with such small amounts of voltage here, the drop on the cable will cause the how do you describe this? It'll cause the relay to keep turning on and off, so you need a separate sensing wire here, and a separate sense wire for your meter, and after that you don't have any problems. So okay, back soon. Okay, so we're on the last cell number 4 from the right, and we're basically on load at this stage. Got our load and sense terminals on that cell to our kilovac, and hopefully see that our trusty motor is spinning away merrily. So this will be the last cell now to need balancing. So when that's done, we'll get the ampere counter set back up again, and we'll be able to charge these guys up, see what we get. Okay folks, at this time we are now bottom balanced. All of the cell packs are between 2.75 and 2.77 volts at rest. We've our power supply turned on, so we're now going to select current, I'll just scroll through. About 10.7 volts on the pack. So there's current. And let's see what this thing can do. I'll try and get 25 amps out of it. There we go. 25 amps, give or take. Let's go to amp hours, voltage, amp hours. So that's it. We're counting amp hours back in. So I'm hoping to get up near 60 in here. So I'm not gonna force you all to sit through that. So we'll come back. We'll come back when we get let's say up over 40 and see how we're faring out at that. Okay, we're just past 40 amp hours into the battery. I managed to get the current up to 30 amps. We've been charging at 30 amps for the past hour or so. And cell number 2 now is just hitting 3.66 volts, which obviously is a function of the current that we're feeding into it. Other cells are about 3.45. So at this point I'd be looking to go into more of a constant voltage routine, I would say, with this. I don't know how well this power supply can do it, but I'm going to try. See what we've got here. Still 30 amperes, 13.9 volts. Yeah, I'm going to reduce to 25 amps. There we go, 25 amps. And 3.66 volts still maintaining. Which is interesting. It is again a facet of the current that we're feeding in. This is the first time that I've had a chance to do any actual capacity testing on these cells beyond some very simple stuff. I've never had a meter that could actually really do this on the bench with previously. Let's see again. Getting a bad feeling about this, folks. Reducing to 20 amperes. The voltage is stabilizing back around 3.64. Somehow don't think we're going to get 60 amp hours. Which does not make me too happy. Okay, back soon. Okay, we're at about 43.5 amp hours in. Got the charge current dialed down to 10 amps now. I think I've got some kind of a good news, bad news kind of a situation. The good news is that the amp hour counter seems to be quite happy. The bad news is that I think I've got a duff cell. I was going to try and over here with the camera for a second. Now, this cell here is the one that's hitting the top of the charge curve first of all. It's at about 3.62 volts now at 10 amps input current. Now, the thing that has me concerned is that the other three are all very close together at the minute. They're in around 3.42 volts. Now, the nail in the coffin is when I happen to put my hand across this here. All of these cells here are absolutely stone cold. This one here is warm. And when my hand along the far side, everything's fine. So I think that one is duff, and possibly one of the middle cells. So that's the bad news. I suppose the other, good news aspect is that I found this out on the bench before I put it in the car. 3.64 now. So, good news, bad news. What we'll have to, I'll have to do now is I will have to strip those cells out of that row tomorrow, and we'll have to do individual capacity test on them, see which one of them isn't holding capacity. And at 3.65 again. And then I guess I'm going to have to order more cells from Manzanita. Amps. Let's take it down to 5. Oh, there. Okay, 5 amps, 6 amps, 5 amps. 44 amp hours in. Around 3.57 volts all of a sudden. Falling. Well, I suppose at 5 amps charging current we're only putting 1.25 amps into each cell on average. Dropping down to 3.552 and dropping. Still a temperature difference on that outer cell. Back voltage is 13.73 and going right to left 3.392, 3.541, 3.377, 3.376. So these two are very close. That one's close enough. Number 2 here is the odd man out. Which doesn't make me too happy. So, settling down to 3.534 now. 5 amps input current isn't much. I'm going to be calling in a day pretty soon. I think about 45 amp hours is where we're going to get, which is way below what I've been looking for. This temperature issue now does have me concerned because none of the other cells are expressing any kind of temperature difference. Even on the other side of the pack there's no temperature difference. I'd say at least one of the cells in that row isn't up to capacity. So there we go, an entire day of watching paint dry. Okay. So I think we're going to be calling it a day around 45 amp hours, which is not good at all. But at least, as I say, we've identified the problem on the bench. So yeah, I think this is a good little meter. Definitely something, even if I never put it in a car, I think I definitely have it as a piece of test equipment. It's starting to creep up again with voltage. So I think I'm going to call it a day at that, and I'll strip out that pack tomorrow, start capacity testing those cells individually. I don't know if I'll be able to do it with that meter. Should be able to, I think. Certainly try anyway. Might have to change around the decimal point on it. Make it a bit more accurate. Okay folks, well, it's going to be the longest, most boring video to date, so hope you enjoyed it. See you all next time.